Welcome to today's deep dive. So today we are exploring a really fascinating business school lecture by Professor Mikhail Kostela, and it's all about the circular economy and sustainability in the business world.
Yeah, it's a huge topic right now.
It really is. And our mission today is basically to decode exactly why the traditional, take, make, waste economic model is just fundamentally broken, and also why just recycling is actually kind of a massive trap.
Right, which is a hard pill to swallow for a lot of people.
Oh, absolutely.
Yeah.
Plus, we're going to get into how this impending wave of international laws is forcing these global giants to completely rewrite how they actually make money. But to understand why this is so urgent, I want you to imagine standing at the bottom of this massive roaring waterfall, but instead of water pouring over the edge, it's just stuff.
Just an absolute mountain of stuff.
Yeah. A never-ending, deafening cascade of metal, plastic, concrete, clothing, electronics.
It's a very overwhelming image, but, well, unfortunately, it's a highly accurate representation of our actual material throughput.
Right. Because if you total up the material weight the global economy uses every single year, you get 106 billion tons of stuff crashing down that waterfall.
That's billion with a B.
Yeah, 106 billion. And you would think with all our modern green technology and all those recycling bins we, diligently sort our trash into, that we'd be catching a massive amount of that material at the bottom and pumping it right back to the top.
Yeah, well, the reality is a staggering wake-up call. I mean, out of those 106 billion tons, only 6.9% actually gets looped back.
Wait, 6.9%? That's it?
That's it? Just
Yeah.
6.9% of our entire global economy is circular. And the figure that truly alarms researchers is that this number is actually falling.
Falling. How is that even possible with all the green marketing we see?
I know, right? But back in 2018, it was 7.2%. We're drawing down the planet's finite stock at just a terrifying rate. We're consuming virgin, untouched materials from the Earth faster than we can even build the infrastructure to recycle them.
Wow. So to fix that falling 6.9% figure, we obviously have to look much deeper than just consumer habits. We have to fundamentally rethink where the true value of a product actually lives and, well, how it dies.
Exactly. The lecture starts by targeting that linear economy, the journey from extraction to disposal. Because just the sheer act of extracting these raw materials from the Earth, that drives about 70% of global greenhouse gas emissions.
That's 70%.
Yeah, and over 90% of biodiversity loss.
Okay, so the environmental crisis isn't just about like what comes out of a tailpipe or a smokestack.
Not at all. It is an inherent feature of a system that just assumes resources are endless and cheap and that waste is always somebody else's problem, which is what economists call an externality.
Right, and so the alternative is the circular model. Professor Kostler breaks this down using a really crucial distinction between biological and technical cycles.
Yes, this is a really helpful way to frame it.
Yeah, so biological materials are things like food or natural fibers that can safely compose back into nature. But technical materials, those are your metals, your plastics, your electronics, things that must stay in a human-made loop.
And the golden rule of thumb here is you have to design a product for one cycle or the other.
Right, like if you glue cotton to polyester, it belongs in neither world. It gets stranded and just becomes permanent dread.
Exactly. And we map the life of those technical materials using a framework called the value hill.
I love this concept.
It's great, right? Picture a literal hill. The value of a product climbs uphill as raw materials are extracted, refined, designed, and manufactured into a finished product.
So it's gaining value at every step.
Right. And it reaches the absolute peak of the hill during its use phase when you're actually holding and using the item. But in our current linear model, once you are done with it, the value just falls right off a cliff straight into waste.
So the goal of a circular strategy is to keep that product near the very top of the hill for as long as humanly possible.
Spot on. And to do that, the framework offers what's called the R ladder. It ranks strategies from R0, which is refuse, basically preventing the use of resources entirely, all the way down to R9, which is recover, which just means burning waste for energy.
Okay, let's unpack this. Wait, so throwing my glass bottle or my old smartphone in the recycling bin isn't actually a big win, because it really feels like we've been conditioned since we were kids to think that recycling is the ultimate environmental goal.
Yeah, what's fascinating here is that recycling actually sits at the very bottom of that R ladder. It's R8.
R8, so it's almost the worst option.
Basically, yeah. I mean, think about your smartphone. It contains just a few pounds of raw materials, right? but it holds hundreds of pounds of value in the complex manufacturing, the cutting-edge design, the software engineering, the labor.
Oh, I see where you're going with this.
Yeah, when you shred that phone to recycle it, you instantly destroy all of that accumulated labor and design value. You are only saving the cheapest part, the raw elements.
Man, we're basically throwing away the masterpiece just to save the canvas and the paint.
That is a perfect analogy. If we simply recycle more without keeping the products themselves in use, which is what we call slowing the loop through reuse and repair, we will literally never close that global circularity gap.
Wow.
Even if we miraculously recycled every single recyclable material on Earth, global circularity would only reach about 25%. Recycling alone cannot save us.
So if making things just to be thrown away or, even making things to be recycled loses all of that built-in value, how do companies actually make money in a circular economy? I mean, if you make a phone or a washing machine that never breaks, don't you just put yourself right out of business?
Well, in a traditional model, yeah, longevity destroys your sales volume. And that is exactly where the circular economy demands an entirely flipped business model.
Okay, flipped how?
You stop selling the product and you start selling the performance. The lecture calls this product as a service, or PaaS. You are basically selling the sizzle, keeping the steak.
Right, and Rolls-Royce was actually doing this back in the 1960s with jet engines, right? They introduced power by the hour.
Yes, a classic example.
The airlines didn't buy the physical engines. They just paid for the thrust delivered. So Rolls-Royce kept ownership of the hardware and handled all the maintenance and overhauls.
Exactly. And we see it in modern industries too, like Signify, which used to be Philips Lighting. They sell light as a service to major airports.
So they own the physical light fixtures.
Yep, they own the fixtures, and the airport just pays for the actual illumination. Commercial laundry businesses use a really similar paper wash model too. The laundry company owns the washing machines in your building, and you just pay per load.
It's like being a landlord versus a home builder. Like a builder might use cheap plastic plumbing because, honestly, it's not their problem once the house is sold.
Right, they just want it out the door.
Exactly. But a landlord owns that asset forever. So it actually pays them, financially, to install expensive copper pipes that will never leak.
But wait, doesn't that just mean we end up owning absolutely nothing, and massive corporations own every single item in our lives? Because that sounds a bit more like a corporate dystopia than like an environmental utopia.
Yeah, that is a very common pushback. But if we connect this to the bigger picture, that shift is the exact moment the corporate incentive completely flips towards sustainability.
Oh, interesting. How so?
Well, when the manufacturer retains ownership of the physical item, the concept of built to last instantly transforms from a profit killer into the most profitable choice possible.
Oh, I see.
Yeah, if that commercial washing machine breaks down in year 3, the manufacturer has to eat the cost of fixing it. So suddenly they start engineering machines to last 15 years instead of the usual 7. The environmental benefit comes from aligning corporate greed with product longevity. That makes a lot of sense, but I replace my phone like every 3 years. Who is actually brave enough to try this PaaS or longevity model in consumer tech?
Yeah.
Because nobody is leasing me thrust or illumination for the device in my pocket.
Right. The smartphone industry is perhaps the ultimate battleground for this tension. The lecture actually provides a brilliant contrast between two very different case studies, Fairphone and Apple.
Okay, let's talk about those. I've heard of Fairphone.
Yeah, Fairphone is a Dutch social enterprise, and they build a completely modular smartphone.
Modular meaning you can take it apart.
Exactly. The back pops off without any special tools. The battery, the screen, the cameras, you can swap them all out using just a standard screwdriver you probably have sitting in a kitchen drawer.
That is so cool.
It is. They offer 5-year warranties, and they guarantee spare parts. On the French Repairability Index, they actually scored a 9.3 out of 10.
Wow.
Yeah. They are a pure slow-the-loop model, optimizing for keeping the device near the top of the value hill. But of course, they struggle with massive scale, performance parity, and price.
Right, because they aren't a trillion-dollar behemoth. Then you have Apple, the massive replacement-driven incumbent.
Exactly. And Apple makes significant circular moves, but in a very, very different way. Like, they have this incredible disassembly robot named Daisy.
Oh, yeah, I've seen videos of Daisy.
And they report that 71% of the aluminum in their product casings is recycled.
Okay, but here's where it gets really interesting. There is a massive twist here called parts pairing.
Ah, yes. the dark side of modern tech repair.
Yeah, so major tech brands use software to lock specific physical components to specific devices. So if you drop your phone, right, and you replace the broken screen with a probably good third-party screen, the software detects it's not the original part.
And it doesn't like that.
Not at all. It actively degrades the phone's function or just throws up constant warning messages. Look at the hypocrisy of that. A company can boast on stage about using 71% recycled aluminum, giving themselves this massive eco-halo, while quietly writing software designed specifically to block repairs and force you to just give up and buy a whole new phone. It's circular theater.
It really is. And this raises an important question for any consumer or regulator to ask. Are you truly circular, or are you just recycling the raw material at the bottom of the ladder while purposefully designing out the repair at the top?
Right, going back to the R ladder.
Exactly. Remember the value hill. Manufacturing makes up roughly 75% of a smartphone's entire carbon footprint.
75% just making the phone.
Just making it. So keeping a phone in use for just one extra year beats almost any recycling game you could possibly achieve. Recyclable and circular are not the same claim.
But companies that are completely addicted to replacement sales, they aren't going to just stop using parts pairing out of the goodness of their hearts. They have a fiduciary duty to sell more units.
Right, they won't do it voluntarily, but they are about to hit a massive, unavoidable wall of legislation.
Okay, this is where the timeline gets crucial. Let's situate ourselves in the current landscape. It's June 2026. Exactly 1 year ago, in June 2025, the European Union's aggressive smartphone rules officially went into force.
And these rules are game changers.
They are. Think about the phone in your pocket right now. How many times have you had to charge it today just to keep it alive? Well, by law, devices sold in the EU now have to survive 45 accidental drops. Their batteries must hold capacity for 800 charge cycles, and companies must guarantee the availability of spare parts for 7 years.
It's a huge shift in liability.
And not to mention, next month, in July 2026, the EU's broad right-to-repair directive fully kicks in, which makes it illegal to block independent repairers. And on top of all of this, the EU is rolling out the Digital Product Passport, or DPP. But how does a digital passport actually enforce circularity?
So, the DPP is basically a digital record accessed by scanning a code on the physical product, but it goes far, far beyond just a basic ingredient list. It actually traps the exact physical and chemical makeup of a device throughout its entire life.
Like what, for example?
Well, for instance, it records the exact chemical composition of the glue used to hold the screen in place.
Oh, wow.
Yeah, so 10 years down the line, an independent recycler can scan the phone, immediately know which specific chemical solvent will dissolve that exact glue without damaging the rare earth metals inside, and disassemble it safely.
That is incredible.
It takes circularity from being an invisible, murky marketing claim and makes it fully visible and scannable.
But we are seeing different approaches globally, right? Like the UK is currently leaning toward a much lighter touch, voluntary first approach. They're focusing heavily on packaging and waste taxes rather than these aggressive product design mandates.
Right. It's a bit more hands-off in the UK right now.
Meanwhile, the U.S. has no overarching federal law, but states are taking charge in a major way. States like Oregon, Colorado, and Washington have explicitly banned parts pairing. That actually makes those specific U.S. states far stricter on tech repair than the UK currently is.
Yes, the state-level action in the U.S. is moving incredibly fast.
But if I'm a massive multinational tech giant, do I really run two separate assembly lines? Like, do I design a dirty, unrepairable phone for London and a clean, unlocked phone for Colorado and Paris?
Generally, no. What you are describing is often called the Brussels effect, or, in the U.S., a state-level equivalent.
Okay, the Brussels effect.
Right. When a market as massive as the EU or a powerful bloc of U.S. states mandates a standard, global supply chains usually adapt to meet that strictest requirement across the board.
Because it's just easier.
Exactly. It is simply too expensive and logistically nightmarish to fragment your manufacturing lines based on zip codes. The sheer weight of this regulatory pressure takes a hidden environmental externality and turns it into an immediate, unavoidable line item risk on a corporate balance sheet.
So the law is actively changing the hardware. But that leaves us with a huge blind spot, which is human nature. The lecture brings up a dangerous hurdle called the rebound effect, or the Jevons paradox. It essentially says that efficiency just breeds more consumption.
Right, and it is a paradox that has plagued economists for centuries. Whenever a technological improvement increases the efficiency with which a resource is used, the overall consumption of that resource tends to increase rather than decrease.
It's like switching to diet soda so you can justify eating 2 cheeseburgers.
Yes, that's exactly it.
You haven't actually reduced your calories, you just shifted where you spend them. In the circular economy, if fixing a phone is suddenly super easy and saves you $200, you might just use that $200 to buy a smartwatch you didn't need in the first place, which completely wipes out the environmental gain. We need an absolute fall in virgin material extraction, not just a higher percentage of recycling.
Precisely. And to see if we can actually achieve that absolute fall, we have to look at the frontiers of the industry to see what is real and what is just more, theater. Take biomaterials, for example. We see companies replacing plastics with mycelium, which is mushroom roots, or bio-based compostable packaging.
Oh, there is a massive trap there. A lot of these compostable materials will not break down if you toss them in your backyard garden or the ocean.
No, they absolutely will not.
They require massive, specialized industrial composting facilities, which run at extremely high temperatures that most cities don't even have. So a well-meaning consumer buys a bioplastic cup, throws it in the regular trash, and it just sits in a landfill emitting methane for decades anyway.
Yeah, it's really frustrating. Then there is the frontier of chemical recycling, which involves breaking plastics down to their molecular building blocks. And the theater risk here is a major loophole called mass balance accounting.
I've seen that term. How does that actually work in practice?
Okay, imagine a giant industrial vat. A chemical company throws 90 tons of virgin petroleum inside and 10 tons of recycled plastic. They stir it all up and process it. Then they pull out 100 tons of newly formed plastic.
Okay, so it's a mix.
Right. But because of a legal loophole, they can isolate 10 tons of that output, label it 100% recycled plastic, and sell it at a premium to a brand desperate for a green label. The other 90 tons are just sold as normal.
Wait, really?
Yeah, so the physical item you are holding might contain absolutely zero recycled molecules, but on paper, they've shifted the credits around. It is an auditor's trick, and many critics rightfully call it greenwashing.
That is wild. Speaking of auditors, measurement is another huge frontier to stop those kinds of tricks. In 2024, the ISO 59000 standards were finally launched.
Yes, that was a huge milestone.
This finally gave circularity an agreed-upon international definition. It moved it from a marketing buzzword you just slap on a billboard into a strictly auditable performance claim, much like carbon accounting.
And we desperately need that rigorous measurement because of the finance frontier. There is a massive capital gap here. The European Investment Bank estimates an €82 billion investment gap every single year for the circular economy.
82 billion euros.
Every year. Because investors want sure bets, and circular models are still seen as risky.
And the stakes are life and death for these companies. The lecture points out that just having big brands promise to buy your circular product isn't enough. Like, look at RenewCell, a company recycling cotton, or Northvolt, the massive battery recycler.
Oh, those are painful examples.
Both had immense hype. Both had demand pledges from massive global brands who said they wanted the materials, and both faced massive financial collapse. Why do they fail if the demand is supposedly there?
Well, because scaling a physical recycling plant takes billions of dollars and 5 to 10 years of patient capital. Traditional venture capital doesn't want to wait 10 years, and banks won't lend that kind of money without guaranteed ironclad cash flows.
So they're stuck.
Exactly. Fashion brands and tech giants won't sign binding contracts until the plant is already built and producing at scale. It is a standoff. The circular company starves to death in the middle, waiting for the capital to catch up to the demand pledges. A brilliant circular design means nothing if the financing isn't patient enough to survive the scale-up phase.
So what does this all mean? When you look at all these loopholes, the bankruptcies, the rebound effect where we just buy more stuff with our savings, are we just putting a high-tech Band-Aid on a bullet wound? Can a global economy actually keep growing endlessly, demanding more profits every quarter, while simultaneously shrinking its physical material footprint?
You've just hit on the unresolved, deeply philosophical debate at the very heart of this entire field. The official line from entities like the EU is a profound belief in decoupling.
Decoupling, meaning separating the two.
Right. It's the idea that through brilliant circular design, strict digital passports, and peak efficiency, we can decouple economic growth from resource consumption. We can keep the GDP going up without generating material waste.
But there's a growing camp that strongly disagrees with that.
Yes, the degrowth or sufficiency camp. They argue that efficiency always hits a physical limit. Because of that rebound effect we discussed, the diet soda and the cheeseburgers, they believe that beyond a certain point, we cannot just consume more cleverly, we have to actually consume less.
That's a scary thought for a lot of CEOs.
It is. The ultimate managerial question for a business leader isn't just how do we make this product circular? It becomes much more existential. It becomes how much of this should we be producing and selling in the first place?
Wow, that is a heavy pivot. It reminds us that true circularity isn't just about throwing your aluminum cans into the correct blue bin so you can feel good about yourself. It is a radical foundational redesign of ownership, of supply chains, and of how value is retained in society.
Absolutely.
And whether companies like it or not, lawmakers across the globe are finally forcing that reality into the boardroom.
It is a complete shift in how we relate to the physical world around us. We are moving from being owners of disposable things to stewards of permanent materials.
To bring this all home, I want to leave you, the listener, with a final exercise. Look around the room you are sitting in right now. Pick 3 physical items that you own. Maybe it's the chair you're sitting on, the headphones you're wearing, or the lamp on your desk. Now, imagine a near future where you don't actually own any of them. You're just leasing their performance from the manufacturer.
Yeah. How would those items look, feel, and function differently today if the company knew they had to take them back, disassemble them, and reuse them in 10 years?
It completely changes how you see your stuff. Suddenly you notice the cheap plastic hinges, the glued-in batteries, the planned obsolescence. Maybe, just maybe, changing our perspective is how we finally stop the roaring 106 billion-ton waterfall of waste and turn it into a gentle, enduring loop. Thanks for joining us, and we will see you on the next Deep Dive.